expansion valve, or an expansion device. You'll hear it referred to as a TXV or a fixed orifice typically, but what it does is expands this liquid we have right here. We have a warm liquid refrigerant on this side of this expansion device, and as it goes through this expansion device, it expands into a lower pressure liquid, and eventually it flashes or expands into a gas. This liquid will travel down this copper tube that goes to what's called the evaporator coil. Now, the evaporator coil has aluminum fins that are attached to it, and what that does is helps the heat from the inside air that's blowing over this coil to absorb into the copper, or the aluminum fins and the copper tube, and then into the refrigerant gas. So where the evaporator coil gets its name is this liquid enters the coil and evaporates, and by the time it gets to the end of the coil, it's totally evaporated and there's no liquid left in it, and so we have a gas by the time it reaches the end of the evaporator coil. So this is our evaporator coil, and the gas exits this evaporator coil and it's picked up all of this heat. So it's a gas. This line will feel cold to the touch, but it's a gas and not a liquid. So it's entering the compressor, and basically a compressor is either a piston type pump or some type of a scroll positive displacement pump. And so many times you'll hear this copper line referred to as the suction line, because it's going into the suction side of the compressor or pump. So the pump is sucking this gas in, and what the compressor or pump does is it compresses or pumps this gas up into a high pressure gas, and this high pressure gas picks up heat as it goes through the compressor and comes out through this copper line and enters what we call the condenser coil. And the condenser coil is similar to the evaporator coil in that its job is to dissipate the heat. So it's also got lots of aluminum fins attached to it to help expand the surface area, and the air blows over this coil and blows the heat out of it. So as this high pressure, high temperature gas travels through this condenser, the gas condenses into a liquid, and that's where the condenser coil gets its name as a condenser. It condenses back into a liquid, and by the time it reaches the end of this coil, it should be totally liquid. Then it travels through the copper tube back to the expansion device and starts the cycle all over again. So we have our evaporator, and then we have our condenser, and we also have what's called the low side and the high side of the system. So that happens right here. The low side, and you'll hear it referred to it as low pressure or low side, and then the high pressure or high side. There are
Hello, John Murray here at Cerma Industries in the research lab. We're here to show you a few more things about the AC. If you've been following it properly, you've just finished up watching the basics of refrigeration. And now we're going to show you some basic tools that we use when treating the AC systems, refrigeration systems, car systems, all the above with our Cerma product. First thing we have here is our Cerma product. This is a 2-ounce bottle. This will treat a 4-ton system, 5-ton system. The main tool that we use here at Cerma is a treatment tool. It comes in a box with the instructions and basically has 3 components. You have the capsule where you would put your product in, a dosing capsule. You would end up screwing it, basically sealing it. And what you've got here is you would rotate this to apply it and treat it. This here is the connector that would go ahead and be connected to a home AC unit. Okay, if you're treating a car, it also comes with a car adapter. And what you do is thread this on here. And then, of course, this adapter would click onto the low side of your car AC system. Now, it can only go on the low side, so don't be afraid to use this tool. Anybody can use this tool. There's many videos up on the site that will explain how to use it, show you how to use it, and in fact, we're going to do that again here, showing on a home unit. Now, there's some tools of the trade to verify that you're actually getting the best out of your system. One of them is an infrared gun for thermal. You can check the register output temperatures, things like that. Some of the new and exciting things that we've got going on at Cerma here is we've come in contact with a company that will provide us with radio transmitters and electricity monitors, okay? Whereas if you're treating a 110 system, let's go backwards, a 110 system, on the bottom it's got 3 plugs. 110, you'd plug into the 1, and you would clip this over the lead that's supplying the power, the black lead going into the unit. Now if it's 220, you'd connect 2 of these and you connect one over each wire. If it's 3-phase, you would connect 3 of them and then go ahead and connect over the wires supplying the power. This unit will transmit up to 7 years, and it will transmit up to 100 foot through walls and show you all your data, your kilowatt usage, your kilowatt per hour, and you can insert your cost of kilowatts per hour, and it will actually tell you how efficient your system's running. Now we use this as a baseline. Before we treat, generally what we'll do is we'll take 2 days of data on the system and then treat it with our products, and then come back and do 2 days of data to see the savings and reduction. Now it's very important to understand with an AC system, the most important thing is clean air flow. As you've seen in the video and in the diagram here, you'll see that it has a high side and a low side, and they're both absorbing or dissipating the heat. You're going to absorb the heat out of the air in the inside, and you're going to place it in the outside, thereby making the room colder. By removing heat, you're just lowering the temperature. So always refer back to this demo here, this diagram behind me, when in doubt. To achieve that, though, we've got to make sure of some very important things. Again, I'll keep saying this again and again and again. Do not treat a unit that has not been checked, because you basically mitigate everything you're doing trying to improve it if, in fact, it has a dirty coil, whether that coil's inside or outside. For the inside coils, you're going to have to use a mirror, and where you change the filter, you'll pull the filter out, put the mirror in, shine a light up, and make sure that those coils are nice and clean, that there's no dust and dirt on them. If there's dust and dirt, it can't absorb heat like it's supposed to. So you're not going to improve anything. You're not going to see a big improvement. And our goal at Cerma is to see an improvement. We're going to cool the air down, make it colder, or remove more heat. And we're going to also short cycle the motor. In other words, if it took 5 minutes to cool the house down before, we want to cool it down in 3, thereby saving you electricity. So number 1 rule, what do? We check the air filter. We check the coil, both outside and inside. If they're not clean, clean them. Outside, you can generally spray them off with a hose, something like that. Inside, there are soap solutions sold at any AC supply that you can purchase, and you spray them up in there and it will clean the coil. All right, make sure that the air cleaner is new and that there's free-flowing air. All right, also before you treat with Cerma, make sure that that system is operating properly. In other words, it's producing a cold feeling at the registers, it's got good airflow. If you hear the unit cycling on, off, on, off, on, off, on, off, that's indicating to you that the system is low on Freon, and you don't want to treat this system because it already needs repair. So you're going to have an AC technician come out and check it to make sure it's operating properly. Now that's only in the case that you feel that it's not operating properly to begin with. So in this next segment, we are going to be utilizing all of these tools that I've described to you here, and we're going to show you how to treat a home AC system, both inside, out. We'll go through the inspection, we'll hook up the electrical monitor, and then we'll see how all this stuff comes together. But again, you should have a good understanding of how it works, and if you don't, call a professional, have them install the Cerma, and just make sure they go through the things that we've discussed. If you feel you want to do it and you just need a little bit of help, feel free to call the Cerma tech line at any time, and someone will be there to help you 24/7. Please respect sleeping times. We don't want to answer a call at 1 o'clock in the morning. So keep it during business hours if possible, and we will go ahead and get any answers you need taken care of. We'll walk you through it. We'll do anything we need to do to make you happy as a Cerma customer. Now, with that said, let's go ahead. We're going to cut away. We're going to go out and get set up so we can show you a home AC system. We're going to go through all of the checks. We're going to go all through the pre-inspection, go through the hookups. We're going to go through everything, and in fact, treat the unit. And we'll get that taken care of, and then you'll have a really good understanding. All right, until then. One of the newer offices here that hasn't been serviced, and we're actually doing a remodel, so bear with me here. This is an inside air handler. We call that the air handler. This is where the heat is absorbed from inside the building, and then we move to the outside unit. Here we have the high side tubing, which is the warm tube and small. And then we have the larger tube that should be insulated with foam. That is the vacuum side. So high pressure and low pressure. Big tube is always low pressure. In this particular unit, we have the filtration unit down there, so we're going to pull it out. This particular unit doesn't even have one, so odds are it's very dirty. We're going to find that out. Now, one of the biggest things we want to do today is show you how to use this electricity meter so we can watch the meter. We're going to unhook and untag the clip. Open the clip like so. Okay, it closes and opens. And what we want to do is put the lead line in between there and lock it down. On this particular unit, we're going to look here, and on the rating is a 208 volt system, so we know it's basically a 220 system. So it's going to have two lines. So we're going to put two transmitters on it, or receivers. So we're going to locate our large lines, and in some cases you'll be able to do it, some cases you won't. You have to go into the box. There's one of them attached. And since it's 220, we want to get both of them. Now this is done so that you understand, it's so that we can watch the total electricity consumption of the entire system, so that we can ensure our customers that we're going to save them money and not just tell them we're going to save them money. So what we're going to do is take those out, get them all hooked up, and they are all hooked up. And then we're going to take our transmitter. This one is a current cost transmitter. And again, one line, two lines. So we're only going to connect two, to 1 and 2. And then we're going to make sure that the back is pulled so that the batteries are transmitting. And you should start seeing this flashing here. And it's going to transmit. It will start, there it goes. So it's now transmitting on power consumption. So we're just going to set this up here in a safe place where it's not going to cause any intrusion, but yet it can transmit. Okay, so we'll just set that right there. Alright, so now that you've seen the inside, this is, remember, air handler. Okay, you're going to connect up your meter, check to make sure it's a 110 or 220. They're different ones. Always remember, the smaller line is to be warm to the touch or hot. Be very careful, sometimes they're hot. This particular unit is pretty warm. That's called the high side supply line. Then on the return line, which is going back to the compressor outside, we have the low side. And the low side is going to be the larger tube and should be insulated from point A to point B. That means fully wrapped and insulated from inside all the way to outside. All right, so we'll make sure of that. Again, check the filter. This one we'll go ahead and replace the filter because it's dirty. We want the system to operate at maximum potential. We have registers up here. We're checking and see if it's putting out cold air, and it is. So we're going to go ahead and move it outside now and go through the rest of the treatment. Okay, we've gone ahead and connected one, but this is how you connect them. It's looking. And sometimes it's real tight inside the box, but you'll make room and then seal it back up. A lot of times you can go back to the fuse panel and pick it up there as well. And that's one, and what we'll do is go ahead and get another one put on here. And you can see what I'm doing. Okay, so we've got one of the leads. This is the 220 unit, so we need the other lead as well to measure the kilowatt usages. Okay, so now that we've got these two connected onto the input leads, we'll go ahead and take another transmitter. And again, 220, so we're going to connect to number 1 and number 2, respectively. This is not a 3-phase system, it's single phase. So we're going to connect 1 and 2. We're going to set the transmitter down. It's already been opened, so it should start taking off. And what we're going to do now is I would seal this up in the box and or bag it. I generally bag them in a Ziploc bag and make sure that the Ziploc, of course, is down. And what we'll usually do is mount them on the unit. Okay? And let them just sit there, and then we'll close this area back up. This particular unit is like this. This is how it was when we found it. So we'll go ahead and find the cover for it, or build one for it, put it on there. So for now, we're just going to set this down, and then we're going to go ahead and go back inside and show you how the meter picks it up. But as you can see, that's how it's connected to the system on the outside of the house. All right, so we've connected to the unit. Now, word of caution, be very careful with this. If you require a licensed electrician to do it, if you're afraid of electricity, please get a licensed electrician. This is very dangerous stuff. In some cases, you can go ahead and shut off the power, and most AC systems, if you look up on the wall within 4 or 5 foot of it, you will find a control box. Okay, and right there we can disconnect the power to make our connection. You can generally find that box right here. We'd open it up and flip the breaker and disconnect. As you can see, we've got both our units hooked up. We've got one outside and one inside, so we're measuring the total usage of both machines. It looks like the inside is using 331 watts, and the outside is using 2.68 kilowatts. So let me back out of here. So this little fancy tool here will allow you to keep a track of all your energy usage. You can put in the kilowatt prices, and if you're on a tiered system, it will allow you to do that. But it just tells us instantly how many watts we're using, and then our cost per month if we were to run it 24/7. And gives us a good start and a good comparison. This is all wireless. All you have is a plug into the wall. The rest of it's wireless. The transmitters will transmit. Now you can use up to 10 transmitters with a single unit. So that means you can do 5 220 volt systems or 10 110 volt systems, and totally grab all the costs involved. So if you've got a freezer and an AC that you're going to be treating, you can monitor both of them at the same time. So what we're doing here is we're setting up the baseline. We're going to go ahead and leave this like this for approximately 2 days, and then we're going to come back and show you what it is. When we treat it, we'll go through the whole treatment process, and then we're going to reset this after recording the data, and we'll go on from there. One thing that you must do is you must pick a thermostatic setting. So if you're going to set it at 68 degrees, you leave it at 68 degrees on the thermostat for the entire test. That's the baseline and this, making sure nobody ever touches those things, because it will influence what we're doing here. Because we want to see cycling times and amp draw to maintain a certain temperature in the environment that you're testing. Okay? So until the data is collected, we'll see you in a little bit, and we'll show you how to go ahead and treat the unit and keep testing with this, and then we'll eventually come up with the final, and we'll finish the video. So again, if you have any questions, call Cerma Tech Support anytime, and we'll answer any of your questions. But this is a great little tool for showing your customers exactly what you're saving them when you do the treatments.
I'm sorry, so Fahrenheit is here. And let's turn back on.
Inside of the outside unit now, and we've got to do a few things. One is, of course, we have the Cerma AC treatment that's going to go into the unit on the low side, and here we have one of our larger treatment units. It's very similar to what you'd receive. It's got the car adapter, which we don't need in this application, so we'll remove it, set that aside. And what we have here is a twist-on unit, and then we have our twister unit here. So what we need to do on this particular unit is, first we need to find out what size it is. How many tons is the unit? And if we look at the serial number or the style number, the model number, you'll see a 36. So that's telling me this is a 3-ton unit. It's rather old, it's been left out in the open, it's not operating very well at all. As far as that, it is working, but you know, could be better. So what we're going to do is take our treatment tool, we're going to unspin it like this and open up the top. And although this is not exactly what we offer a smaller unit, it's basically the same. It screws in, screws out. So for a 3-ton unit, first two tons is 1 ounce. Every additional ton is going to be a 1/4 ounce. So we would treat this with 1 1/4 ounce. So I'm going to set this to where I can see it. And we're going to go ahead and pour the treatment into this unit all the way up to the threads. So we try and alleviate any air that's in the system. A little tiny bit of air is not going to hurt anything. And we're going to screw back on the top until it seats. It's very important to take your time with this. We're not in a rush. Okay, now I'm going to have to get in the camera's way a little bit, but now we have this unit here, and we find the larger of the two hoses. That's the suction line. It's generally the cold line. Not generally, it is. And we're going to want to connect to that line. So I'm going to make my connection here with the unit running, always with the unit running. And once I have made my connection, I'm going to hold the treatment applicator and I'm going to slowly start administering the treatment to this unit. Okay. And you want to wait a second. You don't want to do it all at once. You just sort of want to work a little bit in, let it run, work a little bit more. And for us, we're done at this moment. We put in our treatment. We're going to reach down and unhook this. Now, here's something very important. You need to check the Orphis for leaks after you disconnect. A lot of times you'll catch a leak on these units. Now you can use soapy water, or you can use your finger with a little bit of spit on it and see if it bubbles. Make sure it's not leaking. If it is leaking, you can take a little pair of hemostats, a fine needle nose plier, something like that, and grab the center pin and pull down to seal it. If you can't seal it, well, then you're going to have a professional come out and change the orifice on it, okay? You know, hopefully we don't have to do that. In most cases you don't. You just pull back on the unit, it's fine. So this unit was just treated. That's all it took. What we generally want to do though is take a look around the unit, and outside here we have coils. Your unit will have coils as well. We want to make sure there's nothing blocking the coils and that the unit is actually blowing air, hopefully warm air, up, okay? And then we're going to let it run. Now this unit is probably in need of a good charge. So we'll see how it affects the amp draw overall though. So let me get set back up inside and we'll take a look at what's going on.
If you look here, this 353 watts is what it's taking to run the air handler on the inside of the house. And the 1.88 kilowatts is what it's taking to run the actual unit outside. So the compressor and the fan out there. So here, so we're having an ambient exchange of temperature of about 22 degrees across the board. Okay, and let's finish this up. Okay, now that we've wrapped up, we've gone through a long thing. I know it's a long movie, but you know what? We need to get everything across to both users, dealers, applicators, get the full understanding of what's going on and an idea of some of the tools that are available to monitor the systems, to validate that you're doing good for the client, because that's the number one thing. All Cerma products, you know, we stand behind them. We don't want anybody having any problems, so we go the extra length to make sure you have full understanding beforehand. You've watched all the video, I hope, and watch it again if you need to. I know it's long, but it's informative and you'll get a lot out of it. But let me go over some things now. In the test you saw, basically, we started out with the unit, the 3-ton unit over there at the other building, drawing 2.68 kilowatts approximately to operate the outside unit. And at that point in time it had an air differential exchange of 16.9 degrees Fahrenheit. That means the ambient air in the room after it's gone through the air conditioner and out. And we measure it both in the room and out with that meter. Now the final, and you'll see that on the split screen, just so we're real clear, the final was 1.88 kilowatts. That was approximately 3 minutes after treatment. So apparently the unit was in dire need of some lubrication and some help. So we went from 2.68 kilowatts to 1.88 kilowatts of usage, all within a few minutes. That's great. That's actually extraordinarily good. Not to be expected on every unit. Every unit is different. Okay. Newer units, you may not see the kilowatt droppage, but what you're going to see in the overall end is the exchange of air temperature. And that's also, in our testing, shown to be the original air transfer or heat absorption rate was a 16.9 degrees Fahrenheit across the coils. On the final, about 7 minutes after treatment, we ended up with a 22 degree Fahrenheit exchange. What this means, okay, these are very, very important. We're talking right there at a 6-degree drop in temperature over pre-treatment. So we've increased the efficiency of the transfer of heat by 6 degrees. That's right away. I mean, it's going to get better and better, but 6 degrees. So if we have a normal size house and we're trying to cool it to 68 degrees, and normally it takes an hour to do it, if we look at this in the proper way, and this is real quick, I'm not doing the math on it, I'm just using my senses here. We're trying to get to that. After treatment, you should be able to get to 68 degrees from the same start point within probably about 40 minutes. Now here's the gist. We have approximately 20 minutes that the unit's not running. So, are we saving electricity? When that unit's not running, you're not using anything. So, regardless if you see a kilowatt droppage immediately at the unit, you may see it, you may not see it. Depends on the unit. Newer units probably will not. Not right away, at least. You will see a differential in temperature, and time of running equals kilowatts. So you're going to end up saving it that way. And I would say, based on what we've done here, we added a savings of about 20% overall. So understand how to look at that. You cannot just take the amp meter readings. That's not going to give you the whole story, because the key ingredient here is that we make the air absorption of the heat transfer work better. If it's working better, it's going to cool faster. If it cools faster, it's going to run less. It's going to move more heat faster than you normally would have. Thereby, it's going to shut down quicker and not run. This is a savings. Documented, proven, all the way from shopping centers, 100-ton units, all the way down to a window unit. It's been proven. So if you're not realizing this, something's amiss. So that comes to our second point. Air conditioning is nothing more than a heat absorber taking that heat and depositing it elsewhere. So it's going to absorb the heat out of the air in your house, take it outside, and dump it. For it to do that, it must have free air movement around the coils. So we're going to verify, first of all, the outside coils are clean. They are not dusty, dirty. They don't have lawn clippings in them. They don't have brush and trees up against them, plants of any sort around them. We want to keep that area clear and free. Make sure that the fan is operating properly. You should be able to put your hand over the top of the unit and feel hot air coming out of there while it's running. If you're not feeling hot air, then you need to have the unit looked at or cleaned by a professional. The next thing is to go inside. Number one overlooked thing. The filter in your air conditioning system restricts flow. If you restrict flow, you restrict absorption of heat and transfer of heat, thereby making the unit work harder to achieve the same goal. So let's verify that the filter is nice and clean and keep it that way. Let's also, while we're in there, pull the filter out, and if you have the availability at the air handler to do this, some units don't, you will take a mirror and look up at the coils and verify that the coils are clean, because coils become dirty over the years. If you have no way of doing that, it might be time to have a professional come out and do just a seasonal checkup and have him check the coil cleanliness. Because if you're dirty on the coils, you're restricting airflow, you're restricting heat transfer, and you're going to pay for it. It's not going to be free. So, optimum performance is clean. Let me say it again. Clean, clean, clean. Everything has to be clean. Now we have to talk about airflow itself. If you have a return register that's down on the wall, the part that sucks the air in and takes it up, make sure that you don't have boxes stacked in front of it. Make sure there's not a desk in front of it. That you don't let your dog sleep right in front of it, because that's going to clog up your airflow at the filter and at the coils themselves. We want to keep that area totally clean of all dirt and dust and things like that, so that we don't suck them into the system. If we do all of these things and we add the Cerma, you should realize a 20 to 30% savings. There's been some situations as high as 50. It just depends on your unit. If you got a brand new high efficiency unit, don't expect to see as much as if you had a 15-year-old unit. Okay? Let's be real here. Cerma will help you save money no matter what. It will be reflected in your service bills. You can either acquire the tools to validate it yourself or wait for your electric bills to come. But pay attention to the application. Always double check and recap all fittings. Make sure nothing's leaking when you're done. All these things will save you a lot of money overall. So with that, this has been John Murray with another Cerma instructional video. We also have the 1-800 line if you need help. Please try and keep it during working hours. Some of us need our sleep. And I know for a fact you're not out working on your air conditioner at 11 o'clock at night. So call me in the daytime if possible, if you need any help. If not, drop us a line via email or call the office during working hours as well. Somebody is always here to help you, and we will work with you to achieve what you're after. All right, with that said, I hope this video has been instructional for you. If you want to acquire any of the tools you've seen used in the video, they will be up on the new website shortly. We're in the middle of revamping our entire website, and it will come out with all the new tools available. All right, until then,